A tech machine refers to a specialized piece of equipment or system designed to automate, enhance, or streamline technological processes. These machines play a crucial role in manufacturing, production, and industrial applications, leveraging cutting-edge technologies like robotics, artificial intelligence, and precision engineering. For example, in a PC case manufacturing factory, tech machines include CNC, computer numerical control machines, laser cutters, and automated assembly robots. These devices ensure precision, consistency, and high production efficiency while reducing human error and labor costs. By integrating such advanced machines, factories can achieve scalable production with optimal quality control, meeting the demands of modern industries. Design and prototyping. The design and prototyping process for PC cases begins with conceptualization, where designers create 3D models using CAD software to visualize the case's structure, features, and aesthetics. This stage involves considering factors like airflow, cable management, compatibility with components, and overall durability. Once the design is finalized, a prototype is developed using rapid prototyping methods like 3D printing, CNC machining, or laser cutting. The prototype is then rigorously tested for functionality, including component fitment, thermal performance, and structural integrity. Feedback from these tests is used to refine the design, ensuring that the final product meets both technical requirements and user expectations before moving to mass production. Material selection. The material selection process involves evaluating and choosing materials based on the specific requirements of the PC case design. This includes factors like durability, weight, cost, thermal properties, and aesthetic appeal. Engineers and designers assess the functionality of materials such as steel for its strength and cost effectiveness, aluminum for its lightweight and corrosion resistance, plastics for flexibility and low cost, and tempered glass for a premium look and durability. Compatibility with manufacturing processes, such as cutting, bending, or molding, is also considered to ensure efficient production. Testing and analysis help finalize the material that balances performance, aesthetics, and cost for the intended application. Sheet metal fabrication. The sheet metal fabrication process involves transforming flat sheets of metal, such as steel or aluminum, into finished components through a series of steps. It begins with material selection, followed by cutting the metal sheets to precise dimensions using techniques like laser cutting, plasma cutting, or water jet cutting. Next, punching is performed to create holes, slots, or ventilation patterns as required by the design. The sheets are then bent into specific shapes using press brakes or automated bending machines. For structural integrity, welding or riveting may be used to join parts together. The fabricated pieces undergo deburring to remove sharp edges, ensuring safety and a smooth finish. Finally, surface treatments like powder coating, painting, or anodizing are applied for durability and aesthetics, followed by quality inspections to confirm the components meet specifications. Injection molding for plastic components. The injection molding process for plastic components begins with the selection of plastic material, such as ABS or polycarbonate, which is melted into a liquid state using a heated barrel. The molten plastic is then injected under high pressure into a precision-engineered mold that defines the shape of the component. Once inside the mold, the plastic is allowed to cool and solidify into the desired form. After cooling, the mold opens, and the finished part is ejected, ready for further processing or assembly. This process is highly efficient for producing complex and consistent plastic components at scale, with minimal waste and high repeatability. Surface treatment. The surface treatment process involves enhancing the durability, appearance, and resistance of materials through various techniques. For metal components, treatments like powder coating, anodizing, or painting are applied to protect against corrosion and provide a smooth finish. Plastics may undergo spray painting or texturing for aesthetics. Before treatment, the surfaces are cleaned and deburred to ensure proper adhesion. The process concludes with curing or drying to set the finish, ensuring a high-quality, long-lasting result. Assembly. The assembly process involves combining all individual components to form a complete PC case. It starts with joining the structural parts, such as the metal frame and panels, using screws, rivets, or welding as required. Plastic components and decorative elements like front panels or bezels are then attached using snap-fit mechanisms or adhesive. Additional features such as tempered glass panels are secured with mounting screws or hinges. Cable management systems, fan mounts, and other functional elements are installed to ensure compatibility with PC components. The process concludes with a thorough inspection to verify alignment, stability, and overall quality. Tempered glass processing. The processing of tempered glass for PC cases begins with cutting the glass to the required dimensions. After cutting, the edges are polished to remove any sharpness and ensure safety. The glass is then subjected to a heating and cooling process known as tempering, which strengthens it by increasing its resistance to impact and thermal stress. Once tempered, the glass may undergo additional treatments, such as tinting or coating, to enhance its appearance or reduce glare. Finally, the tempered glass is carefully inspected for any defects before being installed into the PC case. Quality control. Visual inspection. Check for scratches, dents, or imperfections. Functional testing. Ensure compatibility with standard PC components, motherboards, GPUs, etc. Durability testing includes stress testing, corrosion resistance, and drop tests. Packaging. Foam inserts, used to protect delicate parts like tempered glass during transit. Sheath, manual or automated packing. Cases are placed in branded boxes along with user manuals and accessories. Logistics, storage. Packaged cases are stored in warehouses. Shipping, distributed to retailers or directly to consumers. Thank you for watching PC Cases Process and Factory.